Welcome. Today's session is about the parabola. F of x equals to a all into x minus p squared plus q. The parabola is the function of the second degree called the quadratic equation or called the quadratic function. Note that y is equals to f of x. Y is equals to f of x. For f of x equals to a all into x minus p squared plus q. 1. Axis of symmetry, which is AS, A stroke S. We call it AS. AS, axis of symmetry, is x equals to p. The axis of symmetry is determined within these brackets, regardless of the degree. When you are looking for axis of symmetry, you ignore the degree. You just put here and say x equals to p. That is the axis of symmetry of a parabola. Then we have what we call the minimum or maximum value. The minimum or maximum value, which is q. Therefore, y will be equals to q. Then we have 3, what we call the turning point, TP. The turning point coordinates are x for p, which is the axis of symmetry, and y for q, which is the minimum or maximum value. Therefore, x for p and y for q. Therefore, the turning point is determined by p, the axis of symmetry, and q, the minimum or maximum value. Now, let us look at the axis of symmetry. If x is 0, then p is 0. So, we won't have any value here except 0. Then the equation will be y equals to x squared plus q. Therefore, the axis of symmetry lies on the y-axis, where x is equals to 0. Let's look at figure 1. Figure 1a. Let's look at figure 1a. Figure 1a, axis of symmetry is 0 and the graph opens up. It means a value is positive. If a value is positive, the q value is the minimum value. If it opens upward, a value is positive. It means the q value is the minimum value. It's important. Everything here is important. Then figure 1b, if a value is negative, it opens downwards, and the q value is maximum. Positive a value, minimum q value. Negative a value, maximum q value. Therefore, the axis of symmetry and the minimum value gives you the turning point. The axis of symmetry and the maximum value give you the turning point. Now we come to number 3. The a and q values effects. How these shape the graph or influence the graph. Number 1, which we are going to talk about this lesson. If a and q have the same sign, their roots are non-real. It means no x-intercept. If A and Q have the same sign, the roots are non-real, no x-intercepts. For A greater than 0 and Q greater than 0, it means they are both positive. Then if A is positive, your Q will give you the minimum value. There it is. Your Q is minimum value and is above the x-axis. There it is. A and Q, if A is positive and Q is positive, your graph will be above the x-axis. For A greater than 0, which is positive, Q is the minimum value. A positive, minimum value. B. For A lesser than 0 and Q lesser than 0, Q is the maximum value below the x-axis. There it is. Maximum below if A is lesser than 0 and Q is lesser than 0, which means they're both negative. We get for A lesser than 0, which means A being negative, Q is the maximum value. A greater than 0, Q is the minimum value. A lesser than 0, Q is the maximum value. Now let us consider the graph of f, which is y equals to x squared plus 4. I'm giving it the name, I'm calling it f, because we have two graphs, f and g, which is y equals to negative x squared minus 4. F is positive x squared, positive 4. Now we start with f, which is y equals to x squared plus 4. Here it is, x squared plus 4. A is 1, positive. Q is 4, positive. A and Q are both positive. Therefore, the roots are non-real. No x-intercepts, because the signs are the same. The axis of symmetry is x, which it still lies on the y-axis. Since A is positive, Q will be the minimum, Q equals to 4. Therefore, the turning point, because the minimum value or maximum value and the axis of symmetry, they give you the turning point. Axis of symmetry is 0, the minimum value is 4. Now we go to the second one. Y equals to negative x squared, negative 4. A is negative and Q is negative, are both negative. A equals to negative 1 and Q equals to negative 4 are both negative. Therefore, the graph doesn't cut or touches the x-axis. It is below the x-axis. Axis of symmetry, it's still 0, and the maximum Q, it's minus 4. The turning point is 0 and minus 4. Now, let's go for non-real roots. If you see non-real roots, you must know your graph doesn't cut or touches the x-axis. Why? For non-real roots, x squared is lesser than 0. Let us consider the graph of f again. We are looking for roots which are x-intercepts. Therefore, when you intercept the x-axis, y will be 0. Therefore, instead of y, we write 0 and we say x squared plus 4 equals to 0. we transpose, we get x squared equals to negative 4. If x squared is negative 4, therefore x squared is lesser than 0. The roots are non-real. No x-intercept. Let's move again to g. G will give you the same value, negative x squared minus or negative 4 equals to 0. Therefore, x squared is equals to negative 4. Therefore, x squared less than 0. Roots are non-real in a set of real numbers. Note, if axis of symmetry lies on the y-axis, maximum or minimum value and y-intercept share the same point. Let us look at the y-intercept. X is 0. Therefore, if x is 0, there we are left with 4. Therefore, coordinates is 4 and 0. There they are, 4, actually 4, 4 and 0. It's 4 and 0. Right. We come to G. The same thing with G. X equals to 0 for y-intercept. Therefore, y is negative 4. Now, remember, the minimum value here, it's negative 4. The minimum value is 4, rather not here. The minimum value is 4. The y-intercept is 4. They share the same point. If the axis of symmetry is 0. If the axis of symmetry shifts from the y-axis where x is 0, whether it shifts either to the left or to the right, the q value will shift with the axis of symmetry, and the y value will always remain on the y-axis. Let me reiterate again. If axis of symmetry lies on the y-axis, minimum or maximum value, which is q, and y-intercept share the same point. They are not one and the same thing. They merely share that spot. If and only if AS lies on the y-axis. But if the axis of symmetry shifts from the y-axis either to the left of the y-axis or to the right, they share different spot. I hope you liked the video. I hope you enjoyed the session. If you liked and enjoyed the session, please subscribe and click the button and like the video. In the next lesson regarding parabolas, I'm going to show you what to avoid. We're going to talk intensively about this value, this one, x lesser than 0. It is very critical. See you next time. Ntate Mnguni signing out.